For this given circuit, we need to estimate the value of V. To obtain the value of V, if we apply KCL here, I can find out the current passing through the 6 ohms resistor branch. That is 1 minus V by 3, because this current is equal to V by 3. According to the current direction, this is positive and this is negative. To obtain the value of V, I would like to apply the KVL for this total closed path. Once you apply the KVL for that closed path, that is minus 6 into 1 minus V by 3 and plus V is equal to 0. With that, minus 6 plus 2V plus V is equal to 0. From this you will get V value is equal to 4 volts. Right. For this example, we need to find out the time which is required to decay the capacitor voltage for its half of its initial value. First of all, you need to know that what is the initial value of this capacitor. To obtain initial value of the capacitor, we need to take the switching action. According to the switching action, before t equal to 0, switch is closed. Capacitor is affecting with the 18 volt source. Nothing but capacitor is having initial voltage. First estimate the initial voltage. To obtain initial voltage, we need to take that at t equal to 0 minus. T equal to 0 minus under steady state, capacitor act as open circuit, switching position is closed. Then by using VDR, we will get the initial voltage 18 volts, 12K, and this is 6K. VC of 0 minus. By VDR, VC of 0 minus is equal to 18 into 6 by 6 plus 4, which is equal to 6 volts. This is VC of 0 plus, which is equal to V0. Since the capacitor, across capacitor, voltage does not change instantaneously, that's why the initial voltage of capacitor is equal to 6 volts. Now we need to estimate the time taken to decay for the voltage of capacitor, it's half of initial value. That means first you need to estimate what is the voltage equation after t equal to 0 for capacitor. Since it is source free circuit, for source free circuit we have to consider the Vc of t is equal to V0 into e power minus t by tau. V0 value 6 volts and tau is equal to Rc, which is after t equal to 0. After t equal to 0, 100 microfarads and 6 kilo. 100 microfarads and 6 kilo, you will get 0.6 seconds. Now once you take that Vc of t is equal to V naught value is equal to 6 into e power minus 0.6 by tau, minus t by 0.6. Once you will get it that, we need to estimate the time value. It's half of its initial value, that is Vc of t is equal to V naught by 2, which is equal to 3. Now 3 is equal to 6 into e power minus t by 0.6. With this you will get 1 by 2 e power minus t by 0.6. From this you will get t value is equal to 0.416 seconds. For this two-port network, we need to estimate the input impedance. Whenever any two-port network is there, input impedance is not equal to Z11 whenever the load is connected. Why? Because Z11 is also input impedance or driving point impedance when the output is open circuit. If the load is connected, input impedance is Z11 is not equal to input impedance. We need to estimate that input impedance. According to that input V1 and I1, and this is V2 and I2. I can take it the load current is minus I2. From that I can define the V2 and I2 relation. V2 is equal to minus 40 times of I2. For the input impedance, we have to take the ratio of Z in is equal to ratio of V1 and I1 when I2 is not equal to 0. Now according to the given Z parameters, I need to define the equations for Z parameters. For Z parameters, we are having the equations. For Z parameters, V1, V2 are depending upon I1, I2. According to the given values, I can take these equations. 4I1 minus 6I2 and 60I1 V2 is equal to plus 8I2. According to the load is connected, I can get the relation V2 is equal to minus 40 times of I2. If you take minus 40 times of I2 here, from the second equation, I can write here minus 40 I2 is equal to 60 I1 plus 8 I2. From this, I2 I can express in terms of I1, that is I2 is equal to minus 60 by 48 I1. This minus 10 by 8 I1. From the first equation, this is the equation number 1 and this is equation number 2. From the equation 1, from 1, I can get the ratio between V1 and I1. V1 is equal to 4I1 minus 6 times of, here I2 value, I can take it minus 10 by 8 times of I1. With this, V1 is equal to 4I1 plus 60 I1 by 8. From this V1 by I1, you will get it 92 by 8. This is 32 plus 60. This is Z in input impedance, which is equal to 11.5 ohms. This is the input impedance of the given two-port network when the load is connected. But for this example, we need to estimate the here power delivered by the 12 volt source. Delivering means you know that for any element, if you want to get the delivered power, the current direction should be from negative to positive. According to the 12 volts power, if you want to get it, I would like to assume the current from negative to positive as I. According to the given circuit, 4 amperes current is incoming here. Then the resultant current in 2 ohms resistor by KCL, I can get it I plus 4. By KCL again, I will get the current passing through the 1 ohm resistance, that is I plus 1. Once you will get the current, here I am able to define the voltage across this one and voltage across this one. Once you will get the voltage across 2 ohms and 1 ohms, I would like to apply KVL for this total closed path for I, because I have to estimate the power delivered by the voltage source. I is required. For that, by KVL for I, the total closed path, I can write minus 12 plus 2 times of I plus 4 minus 6 starting terminal I have taken plus I plus 1 times of 1 is equal to 0. From this you will get it. This is plus 12 and 2 into 4, 8. You are getting minus 4 and 2I. This is I. 3I you are getting. Now 3I is equal to, this is 8 minus 4 and minus 6, 10. 10 plus 1, I value you will get it from this equation is equal to here 9. From this I is equal to 3 amperes. Once you will get the I value, automatically you will get the value of power delivered by 12 volt source. P is equal to product of voltage and current, which is 12 into 3, 36 watts. The delivering current convention from the negative to positive, that's why you can take it here, power deliver, P deliver according to the current convention. For this AC circuit, we need to estimate the active and reactive power consumed by the load circuit. Once you apply any AC excitation, from the load, we can expect that two types of powers whenever the load is having active and reactive element, which is inductor or capacitor and resistor. According to the given load, load is having capacitive load. That's why across resistor, we will get the active power. Across capacitor, we will get the reactive power. This you can do it in two ways. Number one is by knowing the total current and applied voltage, you know that, and total impedance angle if you get it. Using that, VI cos phi is the active power, VI sin phi is the reactive power. But instead of that, once you take that, the load circuit is having resistance as well as reactance. You know that the output power which we are getting across resistance is active power, across reactance is nothing but reactive power. I would like to estimate first the magnitude of current, because once you know the magnitude of the current, the power which is occurred across resistance is active power, that is I square into R I would like to consider, and reactive power which is across reactance, which is I square into XC, directly can get it. Once you take the total current magnitude, only I want magnitude, I need not go for any phasors. You need not go for any calculator part for this one. Now, once I take that total current, your applied voltage according to this Vm sin omega t, this is the maximum value. Applied voltage is RMS value. That's why V by Z I can take it. This Z is total impedance. Only magnitude I am considering. That is here 40 volts, and the total magnitude if we take it 3 plus 5 which is equal to 8, because all are connected in series, plus 8 and minus 2, this is plus J6 we are getting. According to this, the magnitude I can take it 40 by 10 which is equal to 4 amperes. Once you get the magnitude of current which is coming to the load circuit, using that I can estimate active power P is equal to I square into R, directly you will get it. That is what 4 square into 5 which is equal to 80 watts. This is the active power. And reactive power Q is equal to, I can also take that I square into magnitude only, XC. XC is here 4 square into 2, 32 VAR, volt ampere reactive. As per the given options, option D is the correct one. As per the given circuit, we need to estimate the current passing through this 5 millihenries inductor at a frequency of 0. You know that for 0 frequency here, once you take the 0 frequency, what about these? Capacitor act as open circuit, inductor act as short circuit. Then the circuit will be like this. Once you see this circuit, the circuit is not having this AC source, only 2 amperes DC source is existing. Since capacitor is open circuit, that's why we can neglect this one. And the effect of short circuit path, since for DC inductor act as a short circuit, that short circuit path current we have to estimate to obtain that. Here the short circuit path current, once you see these 6 and 3K both are connected in parallel, like that 4 and 12 both are connected in parallel. The current which is coming from the source is here 2 milliamperes, like that. The current is leaving from this combination is 2 milliamperes. I can get it that short circuit path current with the resultant of current in 6 ohms and current in 4K. Both current in 6K and current in 4K we need to get it. By KCL you will get that. To obtain the value of 6K, I would like to take the CDR, current division rule. By CDR, I will get the I6 is equal to, I6 value is equal to total current 2 milli into 3K by 3 plus 6. With this, you are getting 2 by 3 milliamperes. Like that, the same current is entering with these two. Since the leaving current is 2 milliamperes, the total 2 milli is dividing into 4K as well as 12K. That's why here I4K is equal to 2 milli by CDR into opposite resistance 12K by 12 plus 4. With this, you are getting 3 by 2 milliamperes. By KCL, if we take two currents are entering and third current is leaving, our required current is this, then by KCL at X, by KCL at X, I can take that I is equal to here I4 minus I6K. Where I4 we got it 3 by 2 minus 2 by 3, which is equal to 9 minus 4 by 6, which is equal to 5 by 6 milliamperes, 0.83 milliamperes. From this circuit, we need to estimate the I value when the energy delivered to 10 ampere source. Remember that energy delivered to means this 10 ampere current source is absorbing. 10 amperes current source is absorbing. Whenever any element, whether it is active or passive, it is absorbing means even though it is source, to protect the KCL and KVL, current direction always from positive to negative when it is absorbing. According to the given data here, the energy delivered to 10 ampere source means this is absorbing. Once you get this data, 10 amperes energy is equal to 12 kilojoules. You know that energy E is equal to here power into time. Energy is given 12 kilojoules, which is power. Power, you know that it is the product of voltage and current for a source into time. This is current source. With that, we can estimate the voltage. Time given 0.5 minute. Minute means here 60 seconds. With that, you will get the 12 into 10 power 3 is equal to V into, this is 30, you are getting 300. From this V value, you will get 40 volts. As per the polarities which we obtained across this, all the elements are connected in parallel. That's why the same voltage appear here. Whatever the voltage we got here, V value, this V value we got 40, same voltage is appearing here. That's why with this voltage, I can estimate the current passing through this. This is 8 amperes. Here 8 amperes is downward direction, 10 amperes is downward direction. To obtain the required value, that is I, we have to take the KCL. By KCL at X, incoming current is equal to 6 plus I is equal to 8 plus 10, where I is equal to 12 amperes. I equal to 12 amperes. Right. For a network, in this example, he was applied that V of t is equal to 100 sin 100t and 150 sin 300t volts, and the current excited from that source with the given circuit I of t is given 50 sin 100t plus 60 degrees plus 25 sin 300t plus 30 degrees amperes. For this circuit, we need to estimate the resultant power factor. Since the applied voltage is operating with two different frequencies, one is 100 radians per second, second one is 300 radians per second. That's why you need to estimate first what is the resultant active and reactive power at that particular frequencies. Once you add the two powers, either active and reactive power, I will get the total active power and total reactive power. Using the total active and reactive power, I can estimate the power factor angle. Once you will get the power factor angle, I will get the power factor. Cosine of phase angle is nothing but power factor. That's why first I would like to take that according to the voltage and current, I can take the total active power. Total active power here, total voltage is equal to, this is maximum value, 100 by root 2 and 50 by root 2. This is RMS value, and phase angle between these two is equal to 60 degrees, cos 60. And according to that, 150 by root 2 RMS value, 25 by root 2 RMS value into cos 30 degrees. From this, you will get the total active power. The total active power, here we are getting 5747 watts. Like that, I can estimate the reactive power Q. Same, 100 by root 2 into 50 by root 2 sin 60 plus 150 by root 2 and 25 by root 2 sin 30. Using this, you will get the total reactive power, which is equal to, here we are getting 6205 VAR, volt ampere reactive. Once you will get the total active and reactive power, I can define total active power P is equal to VI cos phi and total reactive power Q is equal to VI sin phi. From that, I can get the tan phi value. By dividing these two, P by Q, Q by P, you are getting tan phi, which is equal to here 6205 by 5747, and tan phi value we are getting, tan phi is equal to 1.08 and phi value you are getting 47.1 degrees, 47.19 degrees here we are getting. Once you will get the phase angle, total power factor angle, then power factor of the circuit cos phi is equal to, or cos 47.19 is equal to 0.679. This is the total power factor of the circuit. Right. From this circuit, we need to estimate the expression for I of t, which is current passing through the 8 ohms as well as 1 by 8 farads. Here, this coupled circuit is existing switching action. According to the switching action, before t equal to 0, inductor and capacitors are not affecting with the source. That's why initial values are not existing. That is the first conclusion which we need to define for the given switching action. Once you take after t equal to 0, after t equal to 0, this is a coupled circuit which is existing mutual inductance. Here, whenever the mutual inductance, as per the dot convention, I1 is entering and I2 is leaving. As per the current direction, I have considered that. I1 I have taken clockwise, I2 also clockwise. As per the current convention, where these two dots both are entering. That's why once you define the equivalent circuit of this coupled circuit, when the two dots are entering, then I can define the equivalent circuit in S domain here. The T equivalent circuit I can define. This is the equivalent circuit. For this equivalent circuit, if both are entering L1 minus M, this you are getting, this is L1 minus M, this is L2 minus M, this is M we are getting. This is the equivalent circuit. We need to estimate after t equal to 0 I of t expression. After t equal to 0, switch position is closed. That's why we have to consider this one. And resistance here, capacitance. Now to get that I of t solution, that is same as I2 of t, I need to consider here to obtain the solution within the time the Laplace domain. Once you provide the Laplace domain for the given t domain circuit, I need to consider here the 20 as a 20 by S and L1 minus M is equal to 2 we are getting, that is 2S, and L2 minus M 3 minus 2 1S, and M here we are getting, that M is 2S, and resistance is as it is, and 1 by CS we are getting, with that 8 by S we are getting, and the closed path currents as per the directions I have taken, I1 of S and this is I2 of S. Now I would like to apply the KVL for the two closed path. By KVL, to obtain the value of I2 of S, since our required value is I2 of S. Now by KVL for the first closed path, I can write 20 by S is equal to I1 of S. Both these 2S and 2S, which is 4S, and I2 direction is minus, which is I2 of S into 2S. This is equation number 1. And if we take the KVL for the second closed path, here we are having I2 term here 2S plus S, 3S plus 8S plus 8, that is I2 term. And I1 term, which is opposite direction we are considering. With that, the second equation I will get 0 is equal to I1 of S term, you will get minus I1 of S into 2S plus I2 of S, because I2 direction we have taken, I2 of S is into 3S plus 8 by S. This is equation number 2. From this equation, I can define, because I need I2 of S, I1 of S, I can take it according to that, I2 of S by 2S into this you are getting 3S square plus 8S plus 8 by S we are getting. If you take I1 of S in this first equation, I will get I2 of S value is equal to, I2 of S is equal to 5 by S plus 2 whole square. 5 by S plus 2 whole square. This is from the first equation. I can get I2 of S is equal to, if you substitute I2 of S value, I1 of S value, this one, you will get I2 of S is equal to 5 by S plus 2 whole square. Once you take the inverse Laplace transformation by ILT, we are getting I2 of t is equal to 5t e power minus 2t. This is also is equal to our required value, which is I of t amperes. But for this given Wheatstone bridge, we need to estimate the galvanometer reading. According to the Wheatstone bridge, which is not balanced, that's why galvanometer is having some current. We need to estimate that current. Usually, whenever if you want to get the current passing through a load circuit or any galvanometer, here we need to take that across that load circuit. This galvanometer is having series resistance 20 ohms. That's why we need to estimate the 20 ohms resistor current. If you want to get it that for this bridge circuit, usually we are estimating across the load circuit Thevenin's equivalent. The Thevenin's equivalent circuit is open circuit voltage and we need to estimate the Thevenin's equivalent resistance. Once you take the open circuit voltage across the galvanometer, which is having series resistance of 20 ohms. Now disconnect that 20 ohms resistor with the galvanometer. Since Thevenin's equivalent circuit we can estimate for any two-terminal network. First you need to make that as a two-terminal network. For that I have disconnected the load circuit which is acting as galvanometer having series resistance is 20 ohms. Now we are getting two-terminal network. For this two-terminal network you have to take the open circuit voltage. Open circuit means current in the two terminal is equal to 0. If there is no current in these two terminals, then the positions of 10 and 30 are series. Not only that, 40 and 50 are connected in series. Once you take this here, the Thevenin's equivalent voltage, I can take this voltage is equal to here algebraic sum of these two voltages. That is, I can apply the KVL for this one here. This voltage is equal to by KVL for VOC. By KVL for VOC, I can take it plus V10, starting terminal here I have taken, here also plus VOC and minus V40 is equal to 0. VOC is equal to V40 minus V10, that is, by VDR I can get V40 and V10. V40 is equal to 36 into 40 by 40 plus 50 minus V10. Again across 30 and 40 VDR, 36 into 10 by 10 plus 30. With this you are getting, this is 4 into, here we are getting 90, 9 4 16 minus, here 9 we are getting 16 minus 9, 7 volts, which is open circuit voltage. This is also called Thevenin's equivalent voltage, V Thevenin's or VOC. Now let us take the R Thevenin's. For R Thevenin's, here voltage source we need to make that as a short circuit. Once you provide that voltage source is short circuit, here we are providing that voltage source is short circuit, nothing but this is short circuit. Then the two terminal across A and B, we have to estimate the equivalent resistance. For R equivalent, here 10 and 30 are connected in parallel and 40 and 50 are connected in parallel. Both are connected in series. Now R Thevenin's I can estimate by considering 10 into 30 by 10 plus 30, 40 and 40 into 50 by here 40 plus 50, which is equal to 90. Here from this we are getting here 30 by 4 plus what it is 200 by 9. From this you are getting 270 plus 800 by 36. This you are getting 10070 by 36. With this you are getting R Thevenin's value is equal to 29.72 ohms. Once you will get this R Thevenin's and E Thevenin's, I can develop the Thevenin's equivalent. From this Thevenin's equivalent, I can estimate the galvanometer reading, which is current passing through the 20 ohms resistor. That is, here this value we are getting 7 volts and this is 29.72. We are adding the load resistance 20 ohms. Then galvanometer reading or I is equal to 7 by 29.72 plus 20, which is equal to, we are getting 0.14 amperes. This is the galvanometer reading. For this given circuit, we need to estimate the IL of 0 plus, which is the initial current of inductor, and IC of 0 plus, that is current passing through the capacitor at t equal to 0 plus. First of all, the given circuit is having switching action. Whenever the switching action is provided, transients will occur when the network is having energy storage elements. Now, in this network, inductor and capacitors are provided. That's why transient responses we are getting after t equal to 0, because sudden changes we are providing with the effect of switch. Now, we need to check it whether the initial voltage and currents are existing capacitor and inductor or not. Once you take that we will get it the initial values by considering the switching action before t equal to 0. Now take that before t equal to 0. Before t equal to 0, switch position is closed. According to this, switch is opened at t equal to 0. Before t equal to 0, switch is closed. Now capacitor and inductors are affecting with the 30 volt source. That's why they are existing initial values. To obtain initial values, take t equal to 0 minus. Now for t less than 0, switch is closed. Inductor and capacitors are affecting at t equal to 0 minus. Inductor act as short circuit and capacitor act as an open circuit. Why? Because before t equal to 0, switch position is closed. Now that is DC circuit. For DC, capacitor act as open circuit, inductor act as a short circuit. Now take the circuit at t equal to 0 minus. This is open circuit voltage we need to estimate, and short circuit current IL of 0 minus. This is VC of 0 minus. Now this is 30 volts. Now we are getting this 20 ohms given, 10 ohms. Now this is 10 ohms given. If you want to get that, here by providing the short circuit, there is no current in 10 ohms. That's why we can neglect this. Then I can take it IL of 0 minus is equal to 30 by 10 plus 20, which is equal to 1 amperes, is same as IL of 0 plus, one of our required value, since current does not change instantaneously in the inductor. This current is initial current. I can take it. And the VC of 0 minus is equal to, once you neglect this, 20 and 10 are connected in parallel. By VDR, I will get the initial value of capacitor. That initial value is VC of 0 minus, which is by VDR 30 into, that is across 20 by 20 plus 10, which is equal to 20 volts. This is VC of 0 plus, which is equal to initial voltage. Now one of the required value IL of 0 plus we got. To obtain the other required value, that is IC of 0 plus, we need to take that circuit at t equal to 0 plus. Now at t equal to 0 plus, switch position is open. Now whenever the switch is open at t equal to 0 plus, at t equal to 0 plus condition, inductor act as a open circuit with parallel current source, and capacitor act as a short circuit with a series voltage source. That short circuit path current we have to estimate. Now once you see the circuit under t equal to 0 plus condition, here we are having, this is 30 volts and 10 ohms resistor, and this 20 ohms, and this is, here capacitor is there. That capacitor, once you take this capacitor, the capacitor is short circuit with series voltage source. According to the switching action, switch is open, here we need to consider capacitor short circuit with series voltage source. Then that capacitor, voltage source and 10 ohms both are connected in series. This is the circuit at that instant. And inductor we need to replace, this 20 ohms is as it is. Inductor we need to replace open circuit with parallel current source. That current source value we got as 1 ampere, and voltage source, initial voltage source V is equal to 20 volts, and this is 10 ohms resistor given. Now I need to estimate the value of current passing through the short circuit path, IC of 0 plus. Now by considering this voltage V, I need to take the KCL at V because I want the current passing through this. V minus 20 by 10, you will get it. Now by KCL at V, by considering that V minus 30 by 10 plus V minus 20 by 10 plus, that is outgoing current, same current, plus 1. Since these all are outgoing currents, I can take it here. What value you are getting? V 2V minus 50 plus 10 is equal to 0. V value we are getting here 20 volts. V value we are getting 20 volts. Once you are getting that V is equal to 20 volts here, then the value of IC of 0 plus V minus 20 by 10, which is equal to 0 amperes.